absolutely. So yeah, Brian asked me to give an update on VDI sizing. Particularly, I wanted to focus on Sizer because obviously that's how most of us are going to be coming to our sizings. So let me go ahead and share my screen here. It's mainly going to be interactive with Sizer. I really don't have many slides for you guys, just a few slides to share with you. But not going to be going through a deck really. Share my screen here. All right, hopefully you can see that.
Yes, we see it.
So I've got really 4 topics that I wanted to go over today. Number 1, vCPUs per core is dumb. That's of course for VDI context. vCPUs per core makes a lot of sense in a general private cloud, general server vert for EUC. I think it makes a lot of sense. We'll get into that in a second. 2, a Sizer core is not a core. This is basically my mantra whenever I'm using Sizer is remind yourself that just because it says core in Sizer doesn't that literally mean that's a core in your output. I'll go into why I think that's the case. 3, Sizer isn't perfect. I wanted to share I don't know if it's a glitch or what it was, but it was we were seeing my counterpart Jason on the West Coast was also seeing something a couple of weeks ago. I posted this, I think, in UC or America's SC somewhere on Slack. There was an update I think a couple of weeks ago where you had to click refresh my stuff. There was some bad math errors. I took some screenshots so I can share that with you. Number 4, users per core has headed down, especially with COVID and work from home and Teams and Zoom and everything else. So those are kind of the 4 themes. Is there anything else anyone wants to talk about today, in particular, and any hot issues, any questions?
Well, any kind of open Sizer issues, gotchas that we should be looking out for as well, Kevin. Like what else is left to be done?
Yeah, I'll share with you what I've seen. I mean, I don't talk to the Sizer folks that often. I'm not as involved with where they come up with the numbers and everything. So I'll just share what I see from using it and some of the gotchas that and things that I kind of like to look at. But yeah, I mean, they're always evolving that tool. So it's that's the thing to keep in mind. It's always going to be it's never going to be static, right? So and that I've seen that affect a lot of times too. If you go back to like stuff that's like a year, 2, 3 years old and try to pull it back up in Sizer, you'll see it doesn't match anything that you did. Although I think that if you don't refresh it, it might still show. But
any increase in seeing requests for maybe like AMD versus Intel, Kevin?
Yeah. Sven did a whole testing. He sent me his draft. I don't know if that was finalized, but we're coming. We should, if it's not already out, we should be coming out pretty soon. A complete report of our testing. I mean, it sounds really promising. I'm always just a little bit of a laggard when it comes to my customers. I want to see some other folks actually do it and get it in production before I'm going to tell everybody to do it. But yeah, I mean it's very compelling, the core density in the AMD series. But I don't have any content or anything to really share on that so far, just because I haven't really seen anyone get to production yet. All I've seen is the draft from that Sven and those guys have been working on.
Hey, Kevin, when you go through the Sizer stuff, can you also incorporate a little bit, even if it's just your opinion, about users per node, right? So we can get pretty dense with cores and storage and all that. Like, what's a good number, right? When you start getting into the thousands of desktops that.
Sure. I'll touch on that. That's a good point. So I wanted to say one thing I was looking at is the most recent iteration of this that we did, and that was actually the last time I got on a plane. Probably it was February to go to Vegas for our our GTS Tech Summit. So Jason actually put together this deck back then. This is a little over a year old now. If you weren't able to attend that session or you haven't refreshed this content, it's great content in this deck. I mean, this is like 50 slides, but there's just a ton. He pulled together a ton of great resources in here, And just a couple of reminders. Remember, like, I mean, CPU is really the big focus, with VDI these days. You really got to be focused on that. And then just keep in mind, there's lots of different approaches to sizing, right? I mean, you can do your own stress testing. You can look at what they're currently using. You can do educated guesses. You can look at, login VSI reports. I mean, there's so many different ways to do it. And so there's just a ton of great content in this deck. So if you haven't seen that recently, I gotta ask Jason. I don't know if this is available anywhere posted, but maybe I'll just post this in EUC King, because it's a great resource. I was actually just rereading it again, preparing for this. So I'm going to kind of assume, you've got a lot of those basics. I'm going to try to get into some of the weeds here and some of the kind of current events, right? And that's kind of my goal here. So just keep that in mind. I don't have time to go through, that hour worth of content. But if you haven't seen that, or you'd like to refresher, it's a great set of content there. So let's jump into this. So the first thing I want to talk about is vCPUs per core is done. And this is where, so I'm a big fan of users per core, right? And this is for Zen apps and desktop, virtualized desktops. It also applies to Horizon and Frame as well. Now, I never really had good data to prove this until Sven actually ran through the numbers here. So this comes from their deck from last year, I believe. And what they actually did is they actually took the same login VSI workload, the same hardware. The only difference they did is they took, instead of doing a 2 vCPU Windows 10 desktop, they added a third vCPU, then added a fourth, then added a fifth, and reran the same tests to look at how much faster did the applications respond, meaning how faster did they load, how much faster was it able to process a file, those kind of things, right? And then they looked at what was the impact to density by doing that. And so these are great numbers here, and it confirms something that I've seen with a lot of customers. And so I'm a big fan of 2, maybe 3 vCPU desktops. Now there are some caveats there, and I'll get into, but one trend that I see a lot lately is, I've got important users, whatever, I'm going to give them all 4 vCPUs. And so one of the things that anytime anyone's ever having performance challenges, density challenges, and they are at 4 vCPUs, the first thing I'd say to do is take away a vCPU from everybody, give everyone 3 vCPUs, and you'd be surprised how that fixes a lot of density issues. And so one of the things you notice here is as you go from 2 to 3, there's a pretty decent bump, 5%, measurable bump. When you go from 3 beyond 3, there's almost nothing, right? I mean, it's like it's like less than 1%. Increase in performance. So, and it goes back to one thing I've noticed a lot with VDI. It's really hard to use to really push more than 3 CPUs in a virtual desktop. I've tried 3D gaming. I've tried 3D modeling, all sorts of like high-end use cases. It's really hard to push more than 3 vCPUs with a real workload. Now synthetics and stuff like that, sure. I mean, you can always do it. I'm not saying you can't do it, but it's really hard to see like a sustained more than 3, maybe 4 vCPUs. That's where a lot of times even people are talking about 6 vCPUs and all this crap. I'm like, no, you're not doing that.
And Kevin, there's a quick question. What about RAM? Like this obviously is looking at one aspect, and so there can be this thought that maybe you're tapped out on RAM as well, or RAM is part of this equation as well.
Yeah, I'm a big fan of sticking with the like the 768, which is what 12 by 30, 12 by 32, 12 by 64. Sorry.
Yeah.
So I'm a big fan of starting that. You can always buy the extra. You'd always double the memory later, if you really need it. I'm a big fan. Like Windows 10, I usually think around 6 gigs of RAM. 4, I just think is really too. A lot of people want to start with 4. I really think 4 is really tight for Windows 10 with the newer builds. At least start with maybe 5, 6. I'm also a big fan of like if your nodes are only like 70% or less memory occupied, just give everyone an extra 512 meg or an extra gig until you can actually use up all that memory, right? I mean, there's no downside to using more memory in the host, and I mean, and memory constraints become CPU constraints, because what happens is as Windows starts to approach, especially above 80% physical memory utilization within a Windows OS, it starts to do a lot more CPU churn because it's trying to it's trying to move the memory back and forth between page file and into the the hot memory. And so, memory constraint can also turn into a CPU constraint as well. And so and giving more memory can sometimes save those CPU cycles and give you a little bit better density. So that's the two big things that you can try to do without, is using more memory you already have and lowering the vCPU count, especially if they're already at 4 going to 3.
Okay. That I think that's helpful thinking about RAM. And I think that this chart highlights one of the things we tend to see in EUC is there's you become a place of marginal returns and knife's edge failures, right? It's like we try to find this balance. And certainly from this chart, it seems like, that 3 vCPU and maybe the RAM is that 6 gigs of RAM per desktop.
Yeah, I mean, I would say start at 2 by 6 and then look at like 3 by 8, 3 by 10, as if your applications are really demanding and the use cases, looks at that's kind of the way I look at it. But again, I mean, there's always exceptions to the rules. There's always, unique customers. You have to, take a closer look. But that's where I'm kind of my default until kind of proven otherwise, right? So the second slide they did here was the density. So this was stronger than I thought, especially going from 2 to 3. So just adding a vCPU, again, this is the same exact workload, right? So, but what happened is if you were at 100 users per node, you lost 12 users per node. And if you were at 100 with 2, you're down to 81 with 4 vCPUs. That's pretty significant. And so one of the things that I've been trying to do is, and one thing I noticed, like if you're on like the older gen, like 3 or 4 year old processors, that the Broadwells and that kind of range, a lot of those, especially with the 3060 model, they were almost all like 2.1, 2.2 gigahertz. At 2 vCPUs, that's not a lot of megahertz per user, right? I mean, you're talking about if you're giving 2 vCPUs and only got 2.1 at the host, the whole user's got 4.2 absolute max, right? Assuming it's available. So in that case, a lot of times they really go to 3 or 4 to get you closer to 6 or 8 gigahertz. If you go with a faster processor, which is much easier to do these days, 2.9, 3, 3.1, well, now 2 vCPUs is really like 6.2 gigahertz. It's like a 50% improvement just in the fact that they've got much faster processors, and you're not paying this. I think a lot of this is really like a scheduler penalty, because if you've got 100 machines, that's 200 threads plus the CVM. You go to 3 vCPUs, that's 50% more threads that the scheduler has to maintain. And I think that's where a lot of these penalties come into play. And I can't remember if this is ESXi or HV, but I imagine it's very, very similar between the different processors. You're adding 50 more threads per node or 100 more threads per node. That's just a lot of extra, 100 or 200 actually, right? If they're 100 VMs. So that's a lot of extra threads for it to manage. And that's where you start getting into ready state. And that's the other thing I see a lot with 4 vCPU desktop environments. They'll be at like 70% utilization, but the ready state is like 5, 6, 7%. It's very high. And it's because really they don't need 4 vCPUs, but you're trying to schedule 4 vCPUs for all these desktops that you can't even push the box, into the upper 70s as a total utilization, because you're just struggling with all the threads.
And Kevin, do you think Hugo has a question about like sizing with megahertz per VDI? Is that kind of like a proxy for user per core rather than certainly vCPU to physical core? Is megahertz per VDI help us in the same way?
So I use megahertz as a secondary after users per core. The problem with users per core is just nice and simple. And a lot of times what it goes back to is I have a lot of just like real world data, because every customer I talk to that we're doing sizing and they have an existing environment, I say, do you have a cluster that you maintain? Yes. How many users? What's the peak users you get? Oh, I get about 700 users. That's about the max I get, day to day. Okay. And what's your CPU utilization, when you're at that peak? Oh, it's about 60%. And how many cores is in that environment? I ask those 3 or 4 questions. I know what their users per core is. Right. And so I've got a pretty good idea without even getting into any console, without having to, pull, spreadsheets, run tools that are going to take, a week to gather data and all this kind of stuff. With those 4 questions, I have a pretty good idea from a users per core perspective what they're getting. Now, I can look at, okay, what megahertz, what gigahertz is their CPUs running at? How old are those CPUs? That can give me some more insight, right? If those are 2.1 gigahertz processor, from 5 years ago, or if those are 2.8 gigahertz processors from 2 years ago, that can make a little bit of a difference in terms of how I'm thinking about that users per core. But ultimately, that users per core is going to give me a pretty good baseline really, really quickly in terms of what their average user looks like. And that's really what I'm getting at, to try to figure out what their next hardware is going to be, or what the next 1,000 users is going to look like, et cetera. So that's why it's so powerful too. If you start getting into vCPUs per core, megahertz, you basically have to look at spreadsheets. I mean, there's just no way you can't just ask a few questions and then figure out what they're using. You have to then pull all the data, get in spreadsheets, and start doing a lot of math, and that's fine too. I mean, there's nothing wrong with that. But that's a much more involved exercise, and that's just going to take you a lot. That's going to take you a lot more time, right?
Okay.
So that's why really, users per core is king. There's a lot more detail, and again, in Jason's deck too, about users per core and some different things. So a Sizer core is not a core. Let's move on. Unless there's any other questions, I'm going to move on to Sizer. So I was playing around in Sizer actually right before I got on the call, trying to figure out what I can show everybody. The first thing I want to do is point out a couple things here. So, let's focus on 1,000 users, because I want to just make everything, divisible by 1,000, so you can kind of see what's going on with the numbers. So one thing that's this, I think most people skip over this. This is why a Sizer core is not a core, because, well, one of the few reasons. The first is this: the Sizer default is an E5 2680 V2. So when I'm talking about a core, I'm usually thinking of a new build I'm going to be building for a customer, right? So, and I'm probably thinking like a 2.8, 2.9 gigahertz better processor or better, right? I'm not thinking of an E5 2680 V2. What is that, like Ivy Bridge or before Ivy Bridge? I forgot what the hell was before Ivy Bridge. So most people don't realize that whenever you're putting all these numbers, we're talking about a 25 2680 V2, unless you go in and change that. So that's the Sizer default. Now let's take a closer look, right? You got your selection of brokers here. And then you've got, now this always, I think there's a lot of stuff in Sizer like trying to be helpful, but for me, when I'm trying to do my own math and trying to simplify things, it just makes my life a little bit more difficult. So one thing here is it tries to add or subtract cores. And that's what I find it weird too. This adds or subtracts cores to you, which to me is a little bit weird. So I haven't even figured out what the baseline is here on this. But this adds or subtracts cores based on whether you're picking newer versions or older versions, something like that. Then you've got these defaults here, right? So now this basically you're looking at a megahertz of an E5 2680 V2, right? That's what Sizer's kind of looking at. But normally what people are focused on is the vCPUs, the vCPU per core, right? This is the easy one, right? Most customers know what vCPUs they're going to assign. vCPU per core, which I said is dumb, but we have to deal with that. That's where this gets really tricky, right? So Sizer here is looking at 6 users per core, right? 12 divided by 2, 12 to 1. And then knowledge worker is 5 to 1. I'm talking about users per core. Power users is 3 to 1, okay? We said we're going to do 1,000. So you can also pick the stuff, by default, it adds, files for VDI. I don't mess with a whole lot of this. I kind of think like most of this is pretty good. Like I leave RF2, I leave 30% compression. I only do deduplication if it's persistent desktops. Anything non-persistent, and I usually just leave it off. So anything non-persistent is not going to have any dedupe, erasure coding, anything like that. Hopefully you guys all know that. I don't even deal with any of that. So I usually skip. Once I get down to about the VGP profile, that's about as far as I usually look at stuff. Okay, so this is a default. Let's do the knowledge worker. So this is 10 to 2, right? So that should be 5 users per core. Okay, so, and we've got 1,000 users, right? So 1,000 divided by 5, that's 200 cores, right? So we go into here and we look at it, 1,000 user tests, 200, right? Wrong, 268.4. where do we get that? I'm pretty sure it's those adjustments. Okay. So the Windows 10 and the Office 2016, they said, even though you said 5 users per core, I just gonna add some extra stuff here. So a lot of times for this, I don't really like this. I just leave no adjustment, and I believe that fixes it so that you get the actual users per core. So this 5 users per core, 1,000 users, this should be 200. Let's see if that's right. Nope, it's 244. Okay. So let me see. Maybe that's, you know what, that might be.
Is it CVM coming in there?
No, CVM's not here yet. I think it might be the Horizon View, because I think I was doing the testing with Citrix. That's what it is. So Horizon View also adds 20% more CPU. So if you do Citrix, well, that's good to know too. If you want to just look at the actual numbers, do Citrix and turn on no adjustment. So that actually gives you the 200 cores. Okay. Okay. So now I've said 200 cores, right? Is what I need. Let me disable the other ones that I was playing with. Disable. Okay, so I've just got my 1,000 user test, 200 cores, right? So I go to solution. A good idea to double check too these numbers. So my workload is here, 200 cores, right? So let's see what it did. It did. Okay, the only edit that I have in here is I said require 2.7 gigahertz processor, 2.7 or better. So nothing lower than 2.7 gigahertz. Everything else is still set to automatic and the defaults. So it sized me out at 4 3070 G7s with the 6240R, 24 cores times 2, 3 gigahertz processor. So, which we know is how many cores? 48 times 4, 192. So anyone notice what happened? I need 200 cores. It gave me 192 and says I'm good at 72%. So again, this is why a Sizer core is not a core. I have 1,000 users. I'm saying 5 to 1. I should have at least 200 cores. And now this is not even accounting for CVMs and everything. What's going on here is because a Sizer core is not a core. An effective raw capacity, you mouse over this eye, it says, okay, you've got 192 actual cores. No, those are actual cores, but we want to calculate Sizer cores. And remember, a Sizer core is an E5 2680 V2. So what it's saying is, really, since these are 3 gigahertz brand new processors, we're gonna, give you about a 60% boost on those cores, and we're gonna call that 303. But is it 303? No, it's not 303. And then from the 303, we'll subtract 16 for the the 4 CVMs, and then subtract your 200, and then we think you're actually at 71%. So realistically, let's take a look at this my way. I would say I'm at 192 cores. Sizer saying I'm at 72%, so I'm using 138 cores. I need 4 CVMs, that's 16 cores. So really, I've only got 122. It's saying I'm using 122 cores for my 1,000 users. 1,000 divided by 122.2. Remember, I size this for 5 users. This is 5 users per core, which was the default for the knowledge workers. So, but really, it's at 8 users per core. So that's like I threw a lot of math at you guys, and I'm sure people are like doing what I do in WebExes and half paying attention. But did anyone follow that? And did I lose any? Was my losing
so
Kevin,
part of it should be that you should select more of what the existing processor is when you go through, because you realize that Sizer uses kind of that weighted CPU model, weighted core model. So select a better processor rather than the default.
Yeah, that's probably a good way around it. It's easy to overlook that. And yeah, that's probably what I would do. Although to be honest, I don't actually do that when I'm sizing. So I don't know why though. I'm trying to think of why I don't do that. Usually I'm doing my own math. That's the thing. Like I throw the stuff in Sizer, but then I do my own math on the actual cores. So I just think doing the actual math when it's users per core math, it's just not that hard. Like I take the CPUs in the see, I would just look at it like this, right? Solution, this is a 3070 G7. It's got 48 cores. So I just look at it as 48, subtract 4 for the CVM, and I wanted 5 users per core. So I can do 220. But really that's like at 100%. So at like, let's call it 80% being full, we're at like 176 users on this. Now, again, 5 users per core I don't really agree with, and 176 users I think is too high because of that. But that's kind of the way I would look at this, and then go 1,000 divided by 176 is 5 points. That's 6 plus 1. That means you need 7 nodes.
And so how do you start to think about that? How many users per node? Like, what are your rules of thumb around density for users?
Well, let's go back to users per core, and then I'll go into that. Yeah, I know you want to go there right now, but let me go back to users per core.
Sure.
That was the last one. Okay, anyone else have any questions about how I got where I did some of that math and where Sizer is calculating it? So you see there's the Sizer default in the workload. There's the 3 adjustments, the broker, OS, Office, and then you've got the weighting on the raw cores here. So you got a lot of weightings on both sides, so it becomes really difficult to see what's going on if there's any error, if there's any math glitches or anything else going on. And it's also easy to think, oh, I'm doing 3 users per core. When you actually do the math, you're actually like 5, 6 users per core because of the heavy weighting. So that's the main issue that I see. All right, so that is, what was the name of that subject again? I forgot. A Sizer core is not a core. That's right. Okay, so the reason I like to simplify the math is because Sizer isn't perfect. I took a screenshot of this because I had a feeling this was going to be bad. So this was the workload. It was 50 VDI users. It had calculated this about 2 users per core, so it was like 24 cores. And I noticed when I was looking at this workload, and see, I didn't notice this at first because I was doing my own math, and I was thinking it was about 67%, 77%. That sounded about right, just based on my own math. But then I was looking, I noticed it had that, hopefully you guys have all seen this. There have been some enhancements made via workloads update scenario. So it's like, they kind of lock it in that state you saw it, but they're saying, hey, we got new algorithms here. Click this button, and then everything gets updated. So I was like, that's interesting. So I was looking at this, and one thing I noticed is that 24.17 cores, but when you actually went to the solution tab, it was 87 cores right here. That should always be the exact same. The total cores, the ones that are not disabled, 24.17. There's no math there. That should be exactly what you see here in the workload total cores. So for some reason, it was showing 87. Once I hit that update scenario button, boom, the workload total fixed itself to 24.17. So I never heard Sizer team say that they had a math error or math glitches or anything like that. They just said they updated the weightings or something like that. But that's what I saw. And then I had a couple other, I saw a couple other, weird things that week as well. And so again, Sizer's not perfect. That's one issue that I saw. And then all of a sudden everything was back to 30%. And I started looking at everything and I'm going like, wait a minute, this math is way off. So we were able to update that sizing. And this would have actually been right, that error should have made it so that you had more. If you had bought the hardware, you had more than you probably needed, which is, probably fine. But, a lot worse can be the other way around when you sell, one thing and then you realize, oh, wow, they actually need a lot more hardware, right? So that was the situation that I saw a couple weeks ago. I didn't provide a whole lot of detail because I didn't want to, call anybody out, but that's what I saw a couple weeks ago and posted in Slack.
I apologize if I missed this earlier. So first of all, thank you for giving us all a heart attack about Sizer. But my second piece is, based on what you just showed us, is there a user per core that you start with for just general VDI workloads?
Yeah, exactly. So that's my last topic here, okay. Users per core. Like kind of where we're at today. What are my baselines? What am I thinking about? I wanted to get into all that, and then that pretty much translates into how many users you should be getting per node, because with the exception of kind of AMD, and now there's like a ton more cores per node. For the most part, that's going to drive your users per node, right? Is the users per core. So my default for the last couple of years has been 3. 3 users per core. So this is talking about kind of your mainstream knowledge worker slash, which to me a task worker and knowledge worker are kind of the same these days. Like there's not, to me, the main thing I'm looking at is like, are they doing like a bunch of their own applications, and are they free to browse the web and do whatever they, and especially and video, and then even worse is if they're doing Teams and Zoom and VDI, and they're expecting to be able to do webcams and seeing 40 camera feeds on the screen at the same time. So that's kind of the knowledge worker, task worker, power users. That's kind of what I'm kind of thinking of, is like how significant are the apps, how much video, and how much like webcams and other like rich media type experience, right? Then you get into like, to me, what's separate is developers, professional design applications, right? 3D applications, and things like that. But everything else is kind of a spectrum. Like, I don't know that people are like, oh, this is a task worker, this is a knowledge worker, this is a power user. I mean, they're kind of bullshit terms, to be honest. So like, I kind of don't think too much about those 3 different things. I think of it as a spectrum, and just trying to figure out a little bit more about the users. And honestly, the best thing is if they're already running virtual desktops, then go look at that environment. That should give you a wealth of knowledge around what users per core they're getting today. And I bring this up all the time, and a lot of times I don't think the customers realizing I'm trying to understand what the user per core is. I'm just asking a few questions, but the only thing I'm trying to figure out for them is what's their user per core. 3 has kind of been my default the last couple of years. When we set up the VDI license, they actually did a bunch of like big data mining and looking at what people bought, how many users were there, and it was somewhere between 0.3 and 0.4 cores per user, which is basically right around 3 users per core. And that's roughly what we built, what we designed the VDI license after that kind of average. So Citrix architects, especially this guy named Nick Rentalin, is a strong guy, knowledge wise and everything. He's been saying for last like 7 years that a really optimized, well architected Citrix environment can get 5 users per core. I on Windows 7, I think that had some weight. I never see anybody on Windows 10 getting 5 users per core doing VDI. Now again, this is single session VDI, right? This is totally different if you're talking about application like Windows server based virtualization, whether that's single session or especially multi-session, right? Like XenApp. So I'm talking about single session Windows 10. So I never see 5, honestly. Like, to me, like the lightest users get like maybe low 4s, but probably I would never size for more than like 3, a better density than 3.5. Maybe 4 if it was like super low, like a kiosk or something. I don't know. But I don't really go above 4. The challenge is it can go way less than 3. Like, we have some customers that are like less than 1. That's a big difference. You go from 3 to 1, that's 3 times the hardware, right? That's 3 times the nodes. So, it's, even though that's where like some of these small numbers are actually make a big difference, right? So my default now is like 2.75. That's kind of the sweet spot I've been looking at lately. But I'm looking at, for a lot of things, like I said, video, Teams, Zoom, and anything else more advanced as well. That's going to bring that down closer to like 2.25, 2.5. Usually, like if I talk to like the really large banks that I talk to, that have like, 6 different, antivirus agents and inventory tools and anti-DLP type or DLP type tools. If you have like a ton of agents on the computer, right, that slows everything down. But even like really bad banks are usually getting like 1.6 to 2 users per core, and that's like they know like they've got like just a lot of extra CPU going on with the different agents and stuff. 3D and developers are usually like in the 1 to 2 range. If it's like really high-end 3D, I'm usually thinking around 1, maybe even less than 1. Like, but definitely no more than like 1.5 cores per user. So like that's like 0.6, 0.7 is about the lowest. So I size anywhere, I guess what I'm saying is I size anywhere between like 0.7 to 4, with the sweet spot tending to be around 2.75. Does that make sense to anybody? Anybody want to tell me I'm wrong or something?
Yeah, and Kevin, do you think because of kind of the work from home, you should, if they're heavy users, you think about the number 2, and if it's just like general, and they're doing Windows 10, it's 3 users per core?
Yeah, I mean, the thing is, people are just trying to run Teams and Zoom unoptimized over VDI. I mean, that's going to kill it. I mean, that's going to go down like below 2 and be pretty poor. If you use the the optimized version of those, where there's an agent on the endpoint device and it offloads a lot of that effort, then you should still be able to stay on that 2.2, around 2.5, maybe 2.25. So I'm not too worried about I'm not too worried about that if it's running optimized. But a lot of people are just trying to just run it as another app without thinking about it, trying to do webcam redirection and right, screen sharing and everything else. That's going to be really poor.
And I think you brought up another good point that Damon is echoing, is like just agents in the desktop where, I have a customer that the security team makes the decision on antivirus, and guess what? It's not VDI optimized, and they're not going to buy something different. And so everybody just has to live with that overhead in the VDI architecture.
Yeah, exactly. The heavily regulated industries, especially like banking and stuff, where they've got just a ton of stuff they have to keep track of. It definitely lowers the users per core. Mm-hmm. Yeah. So that's a little bit of kind of the deeper side of the deeper dive of kind of how I think about VDI sizing, how I use Sizer, and what are the things I look at. And I hope that was valuable to you guys. And just one reminder, if you guys ever need assistance, on a particular opportunity, you can go to any opportunity, and let's see, so this is the Hartford. We'll take a look at this. Third section down, it's in the quote details section on the right-hand column. There's a specialist or architect engagement. Just click on that field and select VDI UC Solutions Architects. That's my team. And then just hit enter twice to save it. And then that'll actually send my team an email. It'll also help us for tracking the opportunity. And then you should get a response usually within a few hours, definitely by the next business day.
Kevin, did you hit the total number of users per node where it's like
for you? Yeah. So if you're thinking, so let's go back, because I think that Sizer was a pretty dense one, right? So that was like the 3 gigahertz, 48 cores. So I mean, I'm thinking like on that one, like 44 cores times 2.75. That's like 120. Yeah, that's about it. Like it tends to run like 80 to 100. It to me is like a good environment. But yeah, I think up to like 120, 130 is like an acceptable range. I just rarely ever see anyone get like above 150 users on a node doing VDI, especially latest Windows 10 and everything. And like not like a non-synthetic, like maybe Login BSI will show that, but that's not like it's a synthetic. There's no agents. There's a lot of. It's not real world, and even 120, I'm like, that seems kind of high. I'd be okay with that because these are, this is a really strong processor, but that's probably not typical.
Right. And so that physical, and there's a question for clarification. And so basically, you're saying physical core like ratio is basically 2 to 3 users per physical core.
Yeah.
Yeah. Okay.
And 3 being more optimistic these days. I mean, yeah.
And Brandon is saying GPU profile brings down the desktops per node.
Oh yeah, absolutely. I mean, generally you can't get more than like 64 users per node if you're doing GPU. There are some exceptions to that with certain configs. Like sometimes you have to do a certain hardware like manufacturer. Like you have to do Dell to get like 3 RTX cards, something like that. Or you have to do Lenovo. You can't do more than 4 T4s on a NX or HPE node. Although there's kind of an exception for HPE, but yeah, you can.
Okay. The HPE can do 5 nodes, T4 cards.
Yeah, with some caveats.
Yeah, lots of caveats. Yeah.
Yeah, I mean, I've got a lot of that documented in EUC King. If you want to just like learn a bunch generally about VDI, I would encourage you to just read all of my pinned stuff, or just read, not even just mine, just read all the pinned stuff, like an EUC King, Citrix, HV, GPU support, those 3 channels. Like there's a ton of good content in there. I mean, some of it that's really old might not be so relevant, but most of it, at least read the stuff from the last, couple years. And there's a ton of good stuff in there. I've got a ton of stuff on GPUs, both Stickied and EUC King and HV GPU support.
And so 120 users and like 2 SSDs, do you think that's fine? But that tends to be one of the Sizer defaults where it just, spits out 2 SSDs for a node.
Yeah, did this do hybrid? Oh, yeah, it's not even hybrid, it's just 2. Yeah, I like 2 really good 2 enterprise SSDs is just like it's never going to be an issue really with VDI. I mean, I've yet to see one issue where IOPS and disk was like a customer issue with VDI.
Okay. You're good, because it's kind of like the way this talk track has gone is kind of like all things being equal with no GPU, the CPU is the yardstick we measure by. Obviously, with GPU, that becomes the yardstick, that becomes sizing measure. I just didn't know if kind of disk factored in when we're talking about, would you rather have 2 3.84s or 4 of the 1.92s?
Yeah, I mean, I'm a bigger fan of having 4, if as a minimum, but 2 doesn't really scare me at all either. But yeah, are 2 3.8s cheaper than 4 1.9s now? Because it used to always be 1.9s was the lowest price per tib.
Yeah, they're pretty close.
So maybe 3.8s are cheaper now, so that's why it's defaulting to that. But I also liked not fully populated, right? So I like to always have some extra space there, because it's always a good idea just in case they're actually using a lot. Because I'm usually pretty aggressive with disk, like for VDI. Like I'm usually thinking non-persistent machines should never really be using more than like 20, 30 gigs per user. So a lot of people have like barely scratch, like a lot of people like barely use like 20, 30% of their disk, like in VDI clusters, because like it's just not using much disk at all. So I usually like to size it small, but then not be, fully, not be fully populated.
Okay. Well, good stuff. Any final questions?
Wow, there's a ton of chat messages.
Yeah, we
just 63 chat messages. I'm sorry, I didn't read any of those.
No, that's fine. I was trying to read some of them to you, Kevin, as we went along.
Okay, cool.
Still, Peter says still seeing mostly full clone VDI, or others seeing that as well?
Like persistent VDI?
Yeah.
Yeah, it's just a mix, I mean, I sometimes I'll see a lot of persistent VDI. I mean, most people will say, persistent VDI is not really a great way to do it because you're not really getting a lot of the benefits of like having a single image and stuff like that. But it's really just to each his own. If you can do it that with it. I think there's a lot of good reasons to do persistent VDI, and just keeping it simple with the application, and profiles and everything else. But most people will try to, go non-persistent, roaming, with a profile solution, some sort of app layering solution, at least some way of getting the apps, separate from the image. But I see, we still see a lot of persistent desktops too. Yeah.
Right. Okay. Well, good stuff. Yeah, I tried to keep up with all the questions, but feel free to hang out and then and see if we missed anything. Kevin, appreciate the time.
Absolutely. Thanks, guys.